So as we know in yesterday's class, we discussed the combination of springs. So combination of springs like a resistors in class 10th. So we can make two combinations. One is series combination and another one is what? Everybody? Another one is parallel combination. So if you have taken series combination, spring one and another, there is a two springs. So where the mass is attached, okay, and it is dragged. So this spring constant is K1 and this spring constant is K2. So what is the total equivalent constant? Equivalent spring constant 1 by K is equals to 1 by K1 plus 1 by K2. So it is just opposite to resistance. Am I right or wrong? I told you or not yesterday? All of you?
Yes, sir.
Yes. Next, there is a spring combination which is called as parallel combination. So two springs are attached parallelly and they have been attached to their mass. So then if you notice the spring constant is K1 and this spring constant is K2. So then what is the equivalent spring constant, everybody? K1 plus K2.
K2.
Okay. But in series connection, resistance, what is the resistance formula of series connection? Equivalent resistance is equals to sum of the individual resistances. Am I right or wrong? Same way,
Yes, sir.
if you notice it in parallel connection, equivalent resistance is equals to what? 1 by Rp is equals to 1 by R1 plus 1 by
1 by R.
Okay. So that is what. So now here, it is just resistance reverse only K will come. If you do the reverse of resistance is only actually spring constant. Clear, everyone? So that is what we have to do. So parallel combination is here series combination. Here series combination. Here is a parallel combination. Do you understand? All of you, can you hear me or not? Aswita? Now today's class we are going to solve derivation for this. So what is the combined combination of spring? What is the combined spring constant in series connection? What is the combined spring constant in the parallel connection? So let us start with the first derivation for spring constant, combined spring constant in series connection. So what is the series connection combined spring constant, everybody? So 1 by K is equals to 1 by K1 plus, all of you, 1 by K2. Okay. So let us take now two springs which are attached. All of you observe very carefully. And there is a spring which we attached. And there is a mass which is attached it. So the mass is M. And the force F is applying on this. So totally the force F is applying on this. So this is what the thing. Now this is the surface. What is this actually, everybody? This is the surface. All of you observe very carefully. Now, if I apply some F force on this M body, so definitely M body will show some displacement X. Am I right or wrong, everybody? All of you? Yes, please. Please respond.
Yes, sir.
Yes or no? So the M body, imagine that M body shifted to somewhere here. Like imagination, I'm imagining M is shifted to here. From here to here, it is travel how much distance, everybody? From initial position to final position, it travel how much distance? X distance. Right or wrong? All of you. Can you able to understand or not? Unless you
Yes, sir.
now. So if the mass of the body is traveled X distance means it is the distance traveled by spring 2 and as well as distance traveled by spring 1. Am I right or wrong? Will you all agree with me, everybody? So the extension of spring 1 plus extension of spring 2, which is only equals to the distance traveled by the mass M. Am I right or not? Yes, please.
Yes, sir.
So this spring will stretch this much distance and this spring will stretch this much distance. The total distance only which is equals to displacement by the M body. Am I right or wrong? All of you respond. So that is what
Yes, sir.
X2. So let me take this, the displacement shown by this one is X2 and the displacement, that is what extension shown by first one is X1. So then what is that X is equals to? Anybody can tell? X is equals to fastly X1 plus
X2.
X1 plus X2. At this point, anybody having doubt, I want to know. Do you all clear, everybody? Understand or not? All of you?
Yes, sir.
Yes. Now, so if I consider this is the one system, all of you observe very carefully, then can you tell me what is the force is equals to? Force is equals to mass into acceleration. So force is equals to what here? The force applied by here. What is the force? All of you, mass into this way. Normally, we know that work done is equals to what? All of you, force into displacement. Am I right or wrong? All of you. So work done by the spring is equals to force into displacement. Now, if you observe very carefully, Newton's second law, yesterday we have done. So if I apply this system, F is equals to, can you tell me what is the force applied by them? Of course, the force applied by here is common for this spring and as well as common for this spring. So if I consider total system, if I consider this is the total system, what is the force applied on the total system, everyone? Yes, please. What is the force applied on the total system? F is equals to equivalent constant into X. Am I right or wrong, everybody? All of you. Spring constant into displacement. That is only the force, total force. Then, what about the X1? Can you tell me what is X1? So, in this case, so I'll take F is equals to, what will come? K1 is K1 into X1. Same way, X2 is equals to what will come? Everybody. Force is equals to what will come? X2 into K2 or K2 into X2. That is what you should understand. Now, the force applied by this one, is it same on both the strings or it is different on different string? Because they are attached in the series connection. That is what is my question. Is the force is same in the both the strings and as well as mass M, or it is different for different springs? That is what is my question to you all. What do you think? All of you?
So same.
They both are attached in series connection. So that what is the force exerted on these two springs and as well as mass M? Is it same or is it different? That is what is my question. All of you?
Same.
Yes, please. Respond everybody. Same it is. Yes or no? So let me combine as it is series connection. Both the springs I will consider as a total equivalent or we can say combined spring constant. I will take it as a single spring. As it is both are series connection, I'll join them together and I'll take it as a M mass, and this M mass F force is applied and it is showing the displacement X means. Then what is the total constant here? K1 or KE? Total is equals to what? I combine both the springs. Both the springs combined. So that what will happen, everybody? Please respond. Both the springs combined means it will become what? KE. Am I right or wrong? Yes. All of you. Now, the force which we are applying is not actually for M or only for spring 2 or only for spring 1. As they all are connected in series connection, the force is same for everything. Means in the sense of the force exerted on first spring, which is equals to force exerted on second spring, which is equals to force exerted on force exerted on combined, both equals to same, which is equals to K into X. That is what mass. Am I right or wrong? Everybody? Clear, everyone?
Sir.
Understand, all of you? Rudresha?
Yes, sir.
Pradosh?
Yes, sir.
Yes. So that is what you should remember. So now, from this, if you observe very carefully, so now we all knows that. So if you notice it, X1. So X1 is equals to what? All of you. X1 is equals to what from this? X1 is equals to fastly F by K1. Next, X2 is equals to what? X2 is equals to what? F by K2. Same way, X is equals to what? F by K. Am I right or wrong? All of you? Yes or no? Please respond. Yes. So what is the X is equals to? We have done. X is
Yes,
equals to X1 plus X2. Am I right or wrong, everybody? All
Yes,
of
sir.
you? Yes. Then what is
Yes,
the X value? X value is F by K equals to X1 value F by K1 plus F2 value F by K2. So F is common.
K2.
I'll write 1 by Ke is equals to F is common 1 by K1 plus 1 by K2.
1 by
FF will get cancelled. So 1 by equivalent spring constant is equals to 1 by spring constant of first spring, 1 by spring constant of second spring. So this is what series connection, when the two springs are connected in series connection. So the equivalent spring constant, this is what the formula. So once again, everybody see, the force exerted on M is same as spring 1 and spring 2. So if I combine them, both the springs, I will consider as the equivalent spring constant is Ke. Then the force exerted on them is equals to, okay. So all three are series, their same force is exerting. Force is not distributing for K to spring 2 separately, spring 1 separately, mass is separately. It is exerting uniformly. So equally. So that what will happen? If I consider this both the springs as together, so then equivalent potential constant, spring constant Ke, and distance is x and force is F. So force is equals to, all of you remember, spring constant into x. That is what K into x. X is equals to, you can see, we have written here, x is equals to K into x. Do you all understand, everyone? Please respond.
Yes, sir.
Yes? All of you? Everybody?
Yes, sir.
Yes. Now, sir, how you got F is equals to? Basically, what is the F is equals to Newton? What is the unit of what is F is equals to? Anybody can tell me? What is the units of force? Units of
Newton.
force, Enara? Pradosh?
Newton.
Yes or no? Now, anybody having doubt how this K1 into X1 formula will come? Do you have doubt, anyone? Yes? If you have, you tell me, I will say it. Do you have it? Okay. So if you have, I will clear you. You can notice it. F is equals to spring constant into R spring K1 or K into X. So what is it? What is the units of spring constant? Anybody can tell? What is the units of spring constant? Newton per meter. And X distance, what is the spring units? Meter. So meter will get cancelled. So finally, what is the units of force? Everybody. Units of force, what? What is this, like dumb fellows? If we have not done spring constant for spring constant units, I have not done. Check your notebooks, you have written or not. Spring constant units is Newton per meter, you have written or not. Numericals we have solved. Verify it, everybody. You have done or not?
Yes, sir.
That is what. So spring constant force is equals to, so of course you have done mass into acceleration is also, what is the final units? Newton only. Spring constant into distance also, what is the unit, sir? Yes, please. Newton only. Clear, everybody?
Yes.
Yeah. So that is how we can come. So force is exerting uniformly. So equally. So that what will happen? So F is equals to K1 X1. F is equals to K2 X2. Or if you consider whole as a single spring, F is equals to K into X. That's all you have to remember. I hope everybody understand this derivation. Pradosh, are you listening or not? No response at all. Yeah.
Yes, sir.
So you should verify the units always. Whatever the formula you're writing, don't think that force equals always mass into acceleration. So spring constant into displacement also is force only. That is what you have to write. So please make it. Once it is completed, then you can tell me, we will go with the series connection, parallel connection. Completed? Mr. Narayan, Mr. Monish, Asita, understand Asita? On hand, Samya? Never speak. Okay, enjoy. Nice. Okay. So this is what about the series connection. Let us come to the now parallel connection. All of you observe very carefully. So now parallel connection means we all knows that. Already we know the formula. So if you know the formula, what is the formula for parallel connection, everybody? What is the things for parallel connection?
1 by K. 1 by K.
Yeah. 1 by F. What is the parallel?
1 by
Sir.
K1 by K2.
1 by K1 is for series, Laksha. For parallel, I am asking now. It is opposite to resistance. What is the parallel connection formula, everybody?
K1 plus K2.
K1 plus K2. Understand, Laksha?
Yes, sir.
It is reverse. For resistance, it is reverse. That is what I am saying, Yogara. Okay.
Okay, sir.
Yeah. Now, spring constant. You not understand, you tell me again, I will go. Listen very carefully. For combination of springs, if it is series combination, equivalent spring constant is parallel combination like resistances, reverse. And if it is parallel combination, then equivalent spring constant is like individual, like resistance in series connection, similar to that. Reverse it is. Reverse of resistance is only spring constant. Okay. All of you? That is.
Yes, sir.
Now, parallel connection. So let me take the spring constant of the spring is K1 and spring constant of the spring is K2. Now, I am applying a force F, and this body is traveled some distance X meters. How many meters, everybody? All of you? X meters. Clear? Now, before, when they are in series, the force is exerting same on the both the springs. So we don't know which spring will extend more and which spring will extend less. Am I right or wrong? That is why both we have taken, this is x1 and this is x2. So both displacement x is equals to what? x1 plus x2. Am I right or wrong? Yes. Now,
Yes.
as the both attached parallelly, now you tell me, is it possible to extend one spring more and one spring less, or both will extend the same? Everyone, I want to know. Same. Understanding? So the displacement shown by this also x, and displacement shown by this also x, because it is not x1 and x2. Do you all understand? Are you getting my point, everybody? I'm asking you people. Clear, everyone? So then, both are showing the same distance means, then the force which is applied on them, is it distributed equally, or it is both same it is? It is distributed. It is distributed. F
Equally.
is distributed what? Equally. Then, total force is equals to F1 plus F2. Am I right or wrong, everybody? Will you agree with me? Yes, please. So in parallel connection, what will happen? Force will divide. Because one body cannot go forward, one spring cannot stretch less. Both the springs will stretch same, so that the body will travel x meters. So force will divide with both the springs. With both the springs. That is what? F is equals to F1 plus F2. Then Fe means what? F means what? Can you tell me the formula? F means what? K into X equals to F1 means what? K1X. K1X plus F2 means what? Fastly.
K2.
K2X. That's all. So all the sides, what is common? X is common. Okay, everybody. So K1 plus K2. So XX will get cancelled. So what is the K? K is equals to what? Fastly. K1 plus K1 plus
K2.
K2. That is what you should remember. So like a normal, guys, if I take two strings, both are exerting like a parallel. So what is the total tension? Everybody, what is the total tension? T plus T, which is equals to how much?
2T.
2T. Understand? Like you can remember that. Pulley case we have done. One tension is T and another tension is T. Then what is the here tension? T plus T, which is equals to?
2T.
All of you. Remember or not? 2T. Everybody clear?
Sir.
Yes. So that is what. So this is the formula for parallel connection. So parallel connection, spring constant, and series connection, spring constant. Hope you all understand very clearly. Anybody having any doubt, you can ask me. Clear, guys? All of you?
Yes, sir.
Yeah.
Yes, sir.
So this is what. Now we will solve one question based upon yesterday's concept and today's concept, and we'll go to the next ones. So remember, all of you, one main important note, and you write it. In series connection, force is same. Where is force is same, but the displacement shown by the springs is not constant. So, but in parallel, what will happen? All of you, in parallel, what is same? Displacement is same. Clear? Aswita, understand or not? So whatever the springs are there, they will show the same displacement. That is what you have to remember. So let us solve one question. So there is a spring, everybody. So observe, this is what my spring. So having a length, how much? L. What is the length of the spring, everybody? L. And spring constant is K. Now, break the spring, the broken in two equal parts. So means in the sense of what is the ratio? 1:2. Fluff you. 2 equal parts, and those two parts connected in parallel. Connected in what, everybody? Yes,
Parallel.
parallel.
To
Okay.
parallel.
Now, then find new K. That is what is the question. Find new K. Okay, new K means what? New spring constant. Okay, everybody. Find the new spring constant. That is what is the question. So it is equally broken. So length will become what? We all know that. I have taught you yesterday's class. It is equally broken. So 1:1 is the ratio. So that this spring is half and this spring is half. So L become what? L by 2. L become what? L by 2. If L become, length become half means what about the spring constant? Yesterday we studied spring constant is inversely proportional to length. If L become half means spring constant will become what, everybody? 2K.
Double.
Here also spring constant will become what? 2K. Now this both are attached in parallel. This both are attached in parallel. So all of you observe very carefully. For having M mass, This spring constant is 2k and this spring constant is also 2k. So let me take this is k1 and this is k2. So in parallel connection, what is the spring constant, everyone? Formula. Just now we have done. So total spring constant is equals to k1 plus k2, which is equals to 2k plus 2k, which is equals to how much amount total? Spring constant is equals to 4k. Okay, so that is how we have to solve the numerical. Understand or not? All of you. That is what. If, for example, these both are connected in series, then what is that? Okay, so then what will happen? This is 2k and this is 2k. So what will happen? 1 by k is equals to 1 by k1 plus 1 by k2. So which is equals to, I'll write it. So 1 by k is equals to 1 by 2k plus 1 by 2k. So what is the LCM, everybody? All of you? 2k is the LCM. So 1 plus 1, 2. So 2 will get cancelled. So k is equals to 1 by k is equals to 1 by k. So new spring constant is equals to k. Am I right or wrong? All
Yes,
of
sir.
you? That is
Yes,
what.
sir.
This is in series and this is in parallel. So please kindly do it. Okay, everybody?
Yes, sir.
Yeah, please solve.
Yes, sir.
Make it quick. Clear, everybody? Understand or not?
Yes, sir.
So that is what. So this is what about the combination of springs in series connection and as well as parallel connection. Hope you all solved. Can you able to solve it or not? Is it okay?
Yes, sir.
Everyone? That is what. So next concept which we are going to study. So which is actually the new thing. You all people are experiencing, everyone we people will experience in our daily life. But we don't know that is only called as what we are going to study now. So that is what it is, pseudo force. What is that actually? We used to call as pseudo force. So pseudo force and as well as I will use a word called as inertial and non-inertial frame. Okay. So that is what frame of reference we used to call as. Okay. So this is not a new topic at all. Just I will brush up the things what we studied in 9th class and then I'll proceed. Now let us see that basically in foundation classes, 9th class itself, we will introduce this pseudo force. So basically pseudo force we used to call as centrifugal force, not centripetal force, centrifugal force. We people already studied the centripetal force. Do you all remember, everybody?
Yes, sir.
Yes, all of you?
Yes, sir.
Yes, sir.
Yes. So centrifugal force is different. Understanding? Now centripetal force is different. So what we studied in centripetal force, so which is always acting towards the center. That is what we used to represent with the FC. Am I right or wrong, everybody? Yes, please. All of you?
Yes, sir.
So that is what. So centripetal force we studied when the body is in any kind of body is in acts a circular motion, so that we can say it is centripetal force which is acting always towards to the center. So which we already studied many classes. Now, so centrifugal force, that is what pseudo force. So what do you mean by that? For example, remember when your father or when your mother, whomever it is, when you are driving, for example, you are sitting in a car, you can see when your father or mother suddenly will take a turn. If you are traveling in a straight road, nothing is there. You people will stick to the seating. So wherever you are sitting, you will be sitting. So as soon as when it will comes to the turning, you can see that if your father or mother will take to the U-turn, you can see we people always will be pushed towards to the mirror. Have you all experienced it, everybody? Even your bus also you can see. When you're traveling, suddenly if the driver will take the turn, always we people will go away from our position, like going out of bus, like we will go and we'll hit the side bus, that and all. Have you experienced it, everybody? Yes,
Yes, sir.
so actually there is nobody is trying to push you away. Actually, when it is taking us, for example, your car is traveling in a circular track, you can see whenever your father will take a turn, always we people will fall like this away from that. So actually centrifugal force is acting towards the center, but we people will be pushed away from it. So that pushing force, actually there is nobody is pushing, we people are feeling it. That is what we will say, the force which we are experiencing, that pushing us away from the position when we are traveling in a circular road or circular track and all. So that is the force which to actually it is not existed, and nobody is actually making it. Is that is what we used to called as, what is the force we used to say? Pseudo force, or we can say centrifugal force. What is to call, everybody? Centrifugal force. So pseudo force also we can say it is actually fake force. I'll teach you what is that. Or we can say it is the imaginary force. We'll just feel it, it is existed, but generally it is not existed. Do you all understand, Rudreswa, Pradosh? That is what. So now mainly if you observe, let us understand. So we all knows that Newton's second law. So many pulley sums and all will solve. Do you remember Newton's second law, all of you? So what is Newton's second law? Change in momentum divided by change in time period. Am I right or wrong, everybody? This is what very standard and accepted Newton's law. Am I right or wrong, all of you?
Yes, sir.
Yes, that is what. Now, so observe very carefully. Basically, the Newton's second law is depends on the observer. Are you clear, everyone? Even see that when I'm teaching the pulley sums, observer is standing on the ground. Am I right or wrong, all of you? So there is a pulley, you can notice it. So the mass is lifting or mass is going up and coming down. So the observer is observing from the ground. Am I right or wrong, everybody? Yes, please. So that is what, whatever the numericals we have solved, everything observer is from the ground. He is not in the pulley or not like inside above the pulley. Is just away from the pulleys and standing on the surface. That is what observer. So Newton's second law completely depends on observer. Newton's law, Newton's second law or Newton's laws. Basically Newton's first law, second law, third law. Everything depends on what, everybody? Depends on the observer. Clear, everybody? So now if I take this for example, this based upon the observer's position, we can take, that is what we used to call as frame. So that is only we used to call as frame. So observe, that is what reference frame, observer's reference, frame of reference we used to call as. So observe very carefully, whenever the observer's acceleration is zero, be very careful, observer's acceleration is zero. When the acceleration is zero, anybody can tell me? When the acceleration is zero, 9th class you might be studied. If the graph is like parallel to x-axis, velocity versus time, by the time, brothers, what is that? Acceleration is equals to what? Acceleration is equals to zero, but velocity is what? All of you?
Constant velocity.
Constant velocity. That is the importance of 9th class. So whenever the acceleration is zero, that is what? Velocity is equals to constant. Velocity is equals to constant. Okay, so then only all the Newton's laws, not only this one, observer's velocity is constant, means his acceleration is zero, then only this is the frame we used to call as inertial frame of reference. What is to call, everybody? Inertial frame of reference. Clear? So in this case, all of you observe very carefully, all the Newton's laws, all Newton's laws is valid. Is it okay, all of you? All the Newton's laws are, yes please, valid. Clear, everybody? Understand, all of you? So if you take everywhere pulley sums or lift sums, have you checked it? Lift sums, the lift M mass is going. So observer made from outside or inside the lift? Everyone, observer we have drawn where? Observer from outside. Am I right or wrong, everybody? Remember the questions are pulley questions, all of you. So everywhere observer is outside. So observer's acceleration is zero. So That is what, then all the Newton's laws are applicable. That is what you should remember. Whenever acceleration of observer is 0, then only we can say it is, what is the frame of reference we used to call, all of you? Inertial frame of reference, where all Newton's laws is applicable or valid. Clear everyone? Now, for example, so imagine there is a lift, all of you, there is a lift. Now my observer is standing inside the lift and there is a mass m is going up. Now you tell me, with respect to observer, the mass m is said to be in state of motion or state of rest. That is what my question to you all people, all of you. Of course, mass is going up, so acceleration is upward. Then if observer is observing this mass, now you tell me mass is appears to be in motion or it is in state of rest. That is what is my question, everybody. At least something you say. No, sir, rest, motion or something you say, then I will say you. Simply listening means what is the use?
Appears to be in motion.
What you will feel? Is it in state of motion or state of rest?
In state of.
See, now here observer is outside the lift, so that now mass m is moving, so you can easily observe it. Now Newton's first law, what you studied, all of you?
In state of motion.
Yeah, what
No.
first you should understand what is motion and what is state of rest. Let me teach 9th class. That is what you should understand. So for example, now two persons are sitting in the same bus. Now you tell me with respect to A, B is state of rest or state of motion. Throughout the journey you will observe state of rest or state of motion.
Rest.
State of rest. With respect to B also, A is also state of rest because both are in same reference. Both are in same reference. Now, one boy will sit in the bus, and another boy will stand outside the bus. Now you tell me, with respect to A, B is in state of motion or state of rest?
Motion.
Motion. And with respect to B, A is also state of rest or state of motion?
Motion.
State of motion. You understand? So based upon the observer's position, that is what we used to call as reference point. 9th class motion chapter beginning will classify either the object is said to be in motion or said to be in rest. That is what. So based upon the observer's point, same object, both are sitting in the same bus in both the same seats, both are appears to be rest. But one get down and one traveling in the bus, both are appears to be in motion. But you understand? Both is depends upon the observer's position. Yes or no, everybody? All of you understand?
Yes, sir.
Yes. So that is what you should remember. So
Yes,
that is what we used to call as reference point. So now you tell, if a person sees the lift is moving, something mass is going from the outside, so that lift is appears to be moving or not, motion or not, all of you, motion. So then observer is standing on the ground, so that acceleration is 0. So that is what we used to call as inertial frame of reference. So all the Newton's laws is applicable. Now, a person is also standing inside the lift and some mass is going upward. Now you tell me, when the lift will start moving up, along with the mass, this person, observer also will go up or not, everybody? All of you?
Yes, sir.
Yes. So whatever the acceleration of this mass, observer's acceleration also same. Then you tell me with respect to observer now, M is said to be in state of rest or state of motion? Everybody?
Yes.
State of? Yes, please. State of rest means the acceleration of observer is 0 or not equals to 0. Acceleration of observer, everybody. Acceleration of observer is 0 or not 0? Acceleration of observer is not
0.
Understanding means velocity changes. So velocity we can change by two ways. Can you tell me what is the ways we can change the velocity? We can change by changing the
Magnitude and direction.
magnitude, or we can change by changing the direction. So as observer acceleration is not equals to 0, velocity keep on changing. Then what will happen? Newton's laws are applicable or not applicable? All of you.
Applicable.
Newton's laws of motion is not applicable. Understand, Aswita? Not valid. Clear, everybody? When only Newton's laws of motion is applicable, acceleration of observer is 0. Then only it is Newton's laws are applicable. If it is not equals to 0, it is not applicable. Now you can see this kind of one. Mainly Newton's laws. second law is not applicable. Clear, everybody? Second law is not valid when observer's acceleration is not zero. Means this is the frame we used to call as non-inertial frame. What is to call, everybody? Non-inertial frame of reference. Clear, everyone? Now, mainly you observe very carefully. In a circular motion, velocity keep on changes or remains constant. I taught you people, in circular motion, velocity keep on changes or remains constant. Direction is keep on changing. So velocity keep on changes or remains constant, everybody. Velocity remains changes. So every circular motion is called as accelerated motion or non-accelerated motion. It is
Accelerate.
accelerated motion. Now, if there is a pulley, all of you observe very carefully. If there is a pulley, now Mr. Observer is seeing from the ground. Imagine this is a ground. Now you tell me, actually the earth motion is very, very slow. Very, very slow. So of course, every time V is changing. So the person who is standing, actually his acceleration is, the body is in acceleration. But as V of the body is extremely small, rate of change of acceleration is very, very small. So we will consider, even though the body is in acceleration, actually it is actually a what? Inertial frame of reference or non-inertial frame of reference, everybody? It is the non-inertial frame of reference. Plus, earth is keep on moving, so that it is accelerated motion. Earth acceleration is not zero, it is not equals to zero. But we are assuming that earth velocity is very, very small. Yes or no, everybody? It is extremely small. So that is the reason we will consider earth acceleration is approximately equals to what, everybody? Approximately equals to zero. Actually, it is not a inertial, non-inertial, it is not an inertial frame of reference. It is a non-inertial frame of reference. But we'll assume that acceleration of the earth is zero, so that observer's acceleration. So non-inertial frame of reference will consider as a what, everybody? We'll consider as a frame of reference. Okay, everybody?
Reference.
Inertial frame of reference. 11 Purima, Mr. Monish, Rudreswa, Sai Karthik, that is what? Inertial frame of reference.
Yes, sir.
Clear, everyone? So this is what you should understand. So what is inertial frame of reference and non-inertial frame of reference? Very, very important. Okay, so please note it down, whatever you studied. Make it quick. Then we will study when observer is seeing from outside, what will happen? When observer is seeing inside, what will happen? So that is all we'll discuss.